All right, so if we're going to talk about chemistry, we got to get to the basics. And it doesn't really matter what branch of science you're talking about. Science is about observing things. It's about finding data and creating your um, understanding of it by making assertions about the data that you've collected. And if you're going to be collecting data, then you're going to be using instruments. And if you're going to be using instruments, then those instruments are going to be giving you numbers. And if you have numbers, those numbers have to mean something. If you're using a tape measure, you're going to be measuring in meters or centimeters. If you're going to be using a chronometer, a watch, you're going to be measuring in seconds. So when we measure things, we have to understand what it is that we are measuring. So very quickly, let me take you through the basics. What I would like for you to do is download the PowerPoint and click on this URL. It'll take you to a very interesting video on YouTube where you will see what happens if you do not measure things correctly. So first target is I can identify the basic quantities that will be used the most in chemistry and be able to identify its SI units because we won't be using English units. We're going to be using the units that everyone around the world understand. Some properties can be observed by the unaided eyes. Others must need an instrument. They must be measured. Scientists use the metric system, or the SI, to report these measurements. So, when and where was the metric system first introduced? It was introduced in France in the 1700s. Why? Probably because France was sick and tired of getting into wars. And I can only imagine that probably some of the wars that they got into was over some kind of measurement differences between England and France. Keep in mind, how they would measure the foot back then would be, well, what's the length of the king's foot? That's why they called it feet. What is the length? Well, if your king died, then your definition for what a foot was would change. Would a British foot be the same as a French foot? No, absolutely not. The 1700s was a revolutionary time, both in England and in France and in Germany. It was the start of modern science. People got really serious about basing their conclusions on facts, on measurements. So it became important to make sure that if you were communicating across the across the countries, across the continent, the units that you were communicating with were going to mean the same thing. So what do we call the standard set of units used around the world? We call it the Système International, or the International System. We get the abbreviation SI from the French, Système International. Why do scientists all over the world use the SI system? Well, first of all, it's based on 10. We no longer have to worry about, okay, a yard has 3 feet, so you have to memorize 3 feet, and there is 12 inches in a foot. Okay, that one's not bad. What about the ounces, the volume? Okay, so there are, I believe, 16 ounces in a pint, and I'm not sure, but I think there are 2 pints in a quart, or is it 4 pints in a quart? The one is 2 and the other one's 4, because the next one over, is it that there are 2 quarts in a gallon, or are there 4 quarts in a gallon? That's very confusing. So everything's based on 10, a power of 10, 10, 100, 1,000, 10,000, 100,000, a million. Everything is based on 10. People all over the world are going to use it regardless of language. If you're in China, they understand what a meter is. They understand what Kelvin is. They will measure it the same way. What are the 7 basic SI units. Okay, every other way of measuring things will be based on these seven. These are it. The gram, which is of course going to measure the amount of stuff. Degrees Celsius is going to measure the temperature or how much energy it has. Seconds is going to measure time. Meter or meter is going to measure length. Mole is going to measure the number of things. It's a word that's similar to the word dozen. Dozen means 12. Well, mole will mean a number that is really, really big, and I do not want to get on it, uh, to it right now. Pascal measures pressure, and Joule measures the amount of energy a substance has. So, what about volume? Volume is very important to us. We buy 2-liter bottles. We buy 100 milliliter substances. Volume is very important to us. Why isn't volume one of these basic units? Well, it's because it's derived from one of the seven. It is created by combining three lengths. What is volume? Volume is length times width times height. And you might say, no, that's only one length. Actually, what is height? Height is the distance from the floor to whatever it is you're measuring. That's length. And what is width? Width is how wide something is, but that's still length. So volume is length times length times length. So 1 cubic centimeter, which is the same thing as a milliliter, by the way, will be 1 centimeter wide, 1 centimeter high, and 1 centimeter long. That's not long. Long. Okay, so volume, 1 milliliter of a liquid would be the amount of liquid you would need to fill a 1 by 1 cube. So what happens if what we need to measure is smaller than our base unit, like the meter? Okay, so you're trying to measure the width of coronavirus, COVID-19. Well, if you're going to take out a meter stick to try to measure the width of a tiny little virus, you are going to have a very difficult time. So the way that the SI system deals with this is we use prefixes to upscale something or to downscale it, to either have a fraction of a meter or to have a multiple of a meter. What are the important SI prefixes and what do they mean? Well, kilo means 1,000 of whatever it's measuring. So if it's measuring meters, that means you have 1,000 meters, we can say 1 kilometer. So why do we use that? Well, can you imagine trying to report the distance between the Earth and the sun in meters? It would be many millions of meters. So what we do is we scale it up to kilometers, and there we're only dealing with thousands of kilometers. A decimeter is 1/10 of a meter. A centimeter is 1/100th of a meter, and a millimeter is 1,000th of a meter. If you're curious, if you wanted to measure a virus, you would probably be dealing with micrometers, which is 1 millionth of a meter. I don't know, it might even be smaller than that, and you would need nanometers, which would be 1 billionth of a meter. Don't worry, we don't have to deal with that in chemistry. What are some examples of some SI lengths? Well, a typical door will be 2 meters. Darth Vader was 2 meters tall. Roughly, it's over 6 feet. The thickness of a paper clip is only 1 millimeter, and a 1 cubic meter box would hold a large dog comfortably, but it's too large a unit to be used in chemistry. We normally do not have to deal with liquids in those amounts. So most of the time we're dealing with cubic centimeters or milliliters. What are the units used for volume and what are the relationships to each other? Okay, this one you really need to focus in on. It is found on the top right corner of the back side of your periodic table. Okay, so you don't have to memorize it, but I would encourage you to do so. Volume is defined as length times width times height. We've already talked about that. The common units, these are the standard units: cubic meter, cubic decimeter, and cubic centimeters. But the most common units that we will use comes from metric. Metric is kind of like an American and Canadian version of it, where we use liters instead of cubic decimeters. And that conversion is 1 cubic decimeter is the same as a liter. They're synonymous, okay? They are synonymous. A cubic centimeter, or in medical shows, you would know it as a cc. So in medical shows, when they're asking for 200 cc's of a certain drug to be injected into the patient, they actually mean milliliters or cubic centimeters. So if you have 1 liter, it's 1,000 milliliters. If you have 1 cubic decimeter, it's the same thing as a liter. Therefore, it is the same thing as 1,000 cubic centimeters and 1,000 milliliters. Okay, so that's the relationship. You can find this around 1 o'clock on the back of your periodic table. What are the different quantities we will be measuring in chemistry and what unit will we use? This you will need to memorize. Okay, it's going to be in your worksheet and you will see it over and over and over again. Mass is the amount of stuff. It's going to be measured in grams. Volume is going to be measured in milliliters or liters or cubic centimeters or cubic decimeters. Temperature is going to be measured in Celsius. That's metric. And that's what we're familiar with, metric. But the SI unit is Kelvin. The difference between them, we'll get to them. The amount of stuff will be the mole. Energy will be joules, and that's named after a scientist. His name was James Joule, and we'll talk about him. Pressure will be measured in atmospheres or kilopascals, and pascals is named after one of my favorite scientists. His name was Blaise Pascal. And time is measured in seconds. So make sure you pause this recording and copy these things down. They're very, very, very important. And that's it.